Hey, welcome back. So now that we understand table relationships in an abstract sense, let's take a deeper look at how they're implemented in the Excel data model. Now, of course, we've actually already added two tables to our data model and even formed a relationship between them, as we see here. But now we're in a position to understand that relationship more deeply. So our first step should be to just interrogate why there is a 1 on one side of this line connecting the two tables, and this asterisk on the other, and even an arrow pointing from the 1 to the asterisk. Well, if you recall from the last video, by far the most common type of relationship between tables is a one-to-many. So you might have guessed that the 1 obviously represents a 1, and the asterisk represents the many side of this relationship. Now we see that the product ID fields in both tables are highlighted, so clearly those fields are the basis of the relationship. And we can also conclude that on the one side of the relationship, in the products table, the product ID field is unique. That is to say, there's only one record in the table per product ID. But on the order details side, a given product ID might be repeated many times, which makes sense considering that our order details table contains a list of line items that were included in each customer order. Obviously, the same products are probably being ordered by many different people, so we would expect the same product IDs to be repeated many times. Now, if you recall, we didn't explicitly specify the direction of this relationship when we established it. We simply dragged between the product ID field of the products table and the product ID field of the order details table. The Excel data model is smart enough to automatically detect which side of the relationship should be on the one side and which side should be on the many side. And in fact, it won't even allow us to establish a relationship unless the field we're using on at least one side of the relationship is unique. So for example, if I had had duplicate product IDs in my products table, the data model would not have allowed me to establish this relationship because it wouldn't truly be a one-to-many. The bottom line is, the Excel data model will not allow you to form a relationship unless at least one side of that relationship involves a field with unique values. Now, as you're building out your data models, if you want more information about a particular relationship and don't remember the exact details behind creating it in the first place, you can always right-click the line and then choose Edit Relationship. And this brings up a dialog box that explicitly declares all the aspects of the relationship, the two tables involved and the two fields involved. So one important thing to understand about relationships in the Excel data model is the roles that different types of tables typically play. The two primary roles are lookup tables and data tables. So data tables typically represent business processes, things like sales, inventory management, or call center operations, and contain the quantitative data that we will ultimately be aggregating in our Power Pivot tables. These data tables should mostly consist of numerical data, the fields that we'll ultimately be summarizing in the data area of our pivot tables. So our order details table here is a good example of a data table. It has 3 ID fields, which are used to either uniquely identify the records in the table, as is the case of the Sales Order Detail ID field, or to relate that table to other tables, as in the case of the Sales Order ID or Product ID fields. The other 2 fields are quantitative in nature and are things that we would be able to sum or average or calculate in some other way in a pivot table. Now, on the other hand, lookup tables typically contain categorical data. That is to say, stuff other than numbers, like product names, employee names, etc. Basically, the kind of fields you would use as row or column headers in a pivot table. So our products table here is a great example of a lookup table. Now, another important thing to remember is the typical relationship between lookup tables and data tables. Almost always, lookup tables are going to be on the one side of a relationship with a data table, with the data table being on the many side. And if you think about it, this kind of makes sense. Data tables are going to contain records of transactions in some type of process, so you may end up with an arbitrarily large amount of records. Whereas lookup tables tend to contain reference information that would change much less frequently. The list of products that our company offers might not change very often, but our company, if it's doing well as we hope it would, should constantly be taking more orders, so our order details table should constantly be growing and adding more records. Now, along with this common dynamic of lookup tables relating to data tables in a one-to-many fashion, you'll also commonly hear people say that you should never / can't relate a data table to another data table. Now, in general, especially if those data tables pertain to entirely different business processes, this is true and a good best practice to follow. But it's not always that simple. In general, you probably shouldn't trust words like always and never. In fact, it is possible for two data tables to be related under certain circumstances. And those circumstances are that a one-to-many relationship still exists between the two. The bottom line with the Excel data model is you can kind of do anything you want as long as you're always relating tables in a one-to-many fashion. You can't have a relationship between two tables that is not either one-to-one or one-to-many. That's the cardinal rule that you just can't break. Everything else is more of a guideline. So an example of this is the orders table among our sample data files. So the orders table contains a record for every customer order, whereas the order details table contains a record for every item within every order. So these two tables are naturally related, and if you think about it, they would have a natural one-to-many relationship. For each one order in the orders table, you could potentially have many items associated with that one order in the order details table. So to see how this would work in the Excel data model, let's go ahead and import the orders table and relate it to our order details table. So first, I'll close out of my data model, and then go to Data, Get Data, From File, Text CSV, and then after navigating to where our sample data is stored, we'll choose the orders file and import, and then we'll transform data just to make sure everything is going to pull in the way we hope. And as it usually does, it looks like Power Query promoted headers and intelligently assigned data types to our different fields, so we should be good to close and load this to the data model. So I'll hit close and load to. We'll only create connection, and then we'll add this to the data model. And now that our data set has loaded, we can go back to our Power Pivot tab and then hit Manage to go back to the data model, and then to our diagram view, where we now see that our orders table has in fact been added to the data model, but does not yet have a relationship established to any other table. But we're going to go ahead and change that right now. So I'm actually going to click and drag this table just to bring it a little bit closer to our orders table. And now let's take a quick second to think about the relationship we're trying to establish. We know that the sales order ID field is the unique identifier in the orders table, so that's definitely the one side of our relationship. And we also know that for every one sales order, there could potentially be multiple records in our order details table for all the items in that order. And it looks like the foreign key, as we learned about in the last video, is sales order ID in our order details table. So what we're going to do is just click and drag from the sales order ID field in our orders table over to the sales order ID field in our order details table. And the Excel data model does the rest. You can see that it's already established a one-to-many relationship between those tables without us having to explicitly say which side was the one and which side was the many. Now at this point, the relationships in our data model really only have two layers. At the lowest level, you have our order details table, and then one level up, you have two tables that are related to that order details table in a one-to-many fashion. But with real-world data sets, it's possible for there to be chains of one-to-many relationships that go many tables deep. For example, while the orders table has a one-to-many relationship with the order details table, we might have a customers table that in turn has a one-to-many relationship with the orders table. And this sort of daisy chain of one-to-many relationships is by no means limited to 3 tables, but could go on for an arbitrary length. So to see what that looks like, I'm actually going to import several more lookup tables and then chain them together using a series of one-to-many relationships. And because I'm quite confident that you've got the basic mechanics of importing data through Power Query down at this point, I'm going to fast forward through this process just to spare you from watching me fumble around with mouse clicks. So here we are finally back in the data model after all of that rapid clicking. And one thing you might notice right away is that there is a little corner of a table peeking at us from the right side of the screen. So we've now dropped so many tables in our data model that we can't even see them all at a glance. Now, while we can use a scroll bar at the bottom of the screen to scroll to the right to see the last table we added, a more efficient approach is often to zoom out so we can see more things at a glance. We actually have a zoom control at the bottom of the screen, so if we click the minus sign there a few times, now, while the representations of the individual tables are a bit smaller, we can see more at a glance, which is usually what we want. So now that we have this view, let's go ahead and start establishing relationships. First up is the relationship between the orders table and the customers table. So we can reasonably conclude that the customer ID field in the customers table is the unique identifier, and that each row in the customers table has information about an individual customer. So this is pretty clearly going to be on the one side of the relationship. On the other hand, we figure that a single customer might place many orders, so that orders should be on the many side. So we'll drag from customer ID in the customers table to customer ID in the orders table. Now similarly, we have a states table that has one row for every state in the United States. And our customers table also has a state ID column with the ID of the particular state that customer's in. This again is a fairly clear one-to-many dynamic because we figure that there might be many customers living in any given state. So we'll drag from our ID field in the states table over to our state ID field in our customers table. And lastly, we have our regions table, which basically categorizes states into different geographic areas. And this table has an ID field that uniquely identifies every region contained in it. And if you look at our states table, there's a foreign key called region ID, which should connect to that ID field in the regions table. Again, a pretty clear one-to-many relationship. So I'll click my region ID field in the states table and drag over to my ID field in the regions table. And again, the Excel data model correctly recognizes the one-to-many relationship. So now at this point, we have a chain of one-to-many relationships stretching all the way from our order details table to our regions table. Now it's important to recognize that this is an entirely distinct chain from the two-table chain stretching from the order details table to the products table. So while the regions table and the states table, for example, are related to the order details table, and the products table is also related to the order details table, the regions table is not related to the products table. And that's because the products table is not part of this daisy chain of one-to-many relationships that starts with the orders table. It's part of its own chain of one-to-many relationships emanating from that order details table. We'll get more into this dynamic later on, but it's an important concept to get used to even now. Now, another way of putting this concept is that relationships should flow downhill, which basically means within these chains of one-to-many relationships, the relationships should always flow from the one side to the many side, all the way from the quote-unquote top of the chain to the very bottom of the chain. So in our example here, you would say that the regions table is at the top of the chain and the order details table is at the bottom. Now, while this is the common way of referring to it, and it is logical and intuitive, because of the orientation of most computer screens and the limited amount of screen real estate, I actually prefer putting my lowest level lookup tables on the left and then having my one-to-many relationships go from left to right until we finally get to our data table all the way at the right. So in that spirit, I'm actually going to rearrange our tables really quick to fit that structure. All right, so if you're comfortable reading this model from left to right, I think that makes the directionality a little bit more clear. Our one chain of relationship goes from regions to states to customers to orders and finally order details. and then our other smaller chain just goes from products to order details. Okay, so now that we've established a strong foundation in data modeling, it's time to actually use our data model how it's intended to be used, as the source for a Power Pivot table. That's up next. I'll see you then.